Hello students, welcome to Sri Jayendra's Rings on Classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 1 of a unit, Alternating Current. So let's begin with today's class. In this session we are just having the introduction of alternating current. In a short, we also call this as an AC. It's an alternating current. So let's begin. We say that electric currents that rises from 0, this is 0, to maximum in one direction, again falls to 0, this is again 0, then rises to maximum in the opposite direction, then from here to here it is maximum but in negative direction, and repeats another cycle. This is the alternating current. So look at this very carefully. This has started from this, reaches to the maximum level, again 0, again maximum but in opposite direction, and again 0. And if it repeats itself, look at this, 0, maximum in positive x direction, again 0, maximum in negative x direction, again 0. So I have taken this snapshot only, but if I see the complete cycle, then this will be repeated itself repeatedly. Yes, this will continue to go on and on. And this is what alternating current is, that my current or my voltage will be changing itself, will change its direction every time. That is what we know as the alternating current or alternating voltage. I hope this is clear. Now, if this was alternating current, then the question might be, what is direct current, that we call as DC? So look at this. This is voltage versus time graph, in which we have placed a one blue line. This blue line represents the direct current. That you can see that direction of the voltage is not going to change. So current or voltage flow in only one direction. That is what we call as the direct. Yes, it's a direct voltage or direct current. So now, do you understand what is the basic difference between direct and alternate? Do you? Great. So let's look. In AC, alternating current, the flow of electric charges is perpendicular in reverse direction, whereas in DC the flow of electric charge is only in one direction. In alternating current, it is always changing its direction, and it's a flow of electric charges perpendicularly. But in DC it is always in the same direction, it is a unidirectional. So this is the basic difference between AC and DC. I hope you understand this. Have you? Great. In direct current there is nothing like a cycle, because it is going to be same every time and each time. But in alternating current there is something like cycle. When I say cycle, I must say that it is the time required, or it would be a combination of those parts which completes one of the fashion. Well, I say fashion, it means we can say this, let's say from this 0, or from this maximum in negative direction, again to 0, maximum in positive x direction, again 0, and again maximum in that direction. This is one of the fashion, or we can say this is one of the pattern. So can this span can create a one cycle. Even you can say like this, that let's suppose this is 0, this is maximum in one direction, again this is 0, again it's a maximum in another direction, and again 0. This is again a one cycle. Yes. So this would be the situation in alternating current, that number of cycles would be there, and we are going to study them. But this are initially we are just discussing the basic differences and basic difference between the AC and DC. Now, what is the one cycle? We can say that it is the time taken by alternating current to go through one cycle of change is called its time period, and that time period could be written as t is equals to 2 pi by omega. We can say so that it is a time required to complete one cycle. But again, the question is, what is one cycle? Again, the question is, what is one cycle? So when I say one cycle, look at this very carefully. I always used to have this, that when we completes our 4 quarters, it's a one cycle. Now, how to define 4 quarters? Let's Your cycle has been begin from here. This is first quarter. This is second quarter. This is third quarter. This is fourth quarter. So your one cycle has been over at here. It's a cycle. But if someone asks me that no, I want to start my cycle from here, what it would be? Then again, count down the begins and let's count for the four. It's a first, second, third, and fourth. I hope you understand. Then this will make your cycle. Yes, this is the length of your cycle. If someone asks me that no, sir, I want to make my cycle from here, let's from this, then make a count of four. It's a first quarter, it's a second quarter, it's a third quarter, of it's a fourth quarter. So this is the length of one cycle. So there is no definition that from this cycle should begin and from this cycle should end. We can always choose our own cycle according to our convenience. I hope this is clear. Is it? Great. So when we say the time period, it is time required to complete one cycle. When I say one cycle of change, when I say one cycle of change, then if I represent this voltage or maximum voltage with respect to angle, then I understand that it is the completion of 360 degree. That means a one complete circle. It's a 360 degree. I hope you understand this. So when I write it's a V is equals to V max sine 2 pi ft. Basically this is V is equals to V max sine omega t kind of situation. This is V is equals to V max into sine of omega into t. So this is V is equals to V max into sine of 2 pi f into t. I hope this is clear. So this omega could be written as 2 pi f into t. I hope this is clear. Is it clear? Is it? Great. So this is V max, that this makes my one cycle. Look at this: first quarter, second quarter, third quarter, and fourth quarter. So as it has completed 4 quarters, it's a one cycle. I hope this is clear. Yes? Great. Now let's define one more term, that is what we call as the frequency. It is the number of cycles per second of an alternating current is called as the frequency. It is the number of cycles per second of an alternating current. That is what we call as its frequency. And that frequency could be written as f is equals to 1 by t. And that would be equals to omega by 2 pi, where omega is the angular frequency of AC. Yes. So we have defined two terms. One is the time period t. It is the time taken by an alternating current to go through one cycle. And we have the frequency. It is number of cycles per second of an alternating current. I hope this is clear. Yes. Even if you want, we can define one more term. Yes, as you have already discussed this and you have already learned this, that maximum displacement, this is the maximum displacement. That is what we call as the, let's say this is the A, while A stands for amplitude. When I define amplitude, it means it is the maximum displacement from the mean position. It's a maximum displacement. Shall I write this? This is maximum displacement from mean position. It is the maximum displacement from the mean position. That is what we call it as an amplitude. So we now understood what is time period, what is frequency, what is amplitude. Yes, great. Now let's have a look. It's a representation of AC and DC sources and voltage waveforms. So let's suppose I am having a DC source. While I say I am having a DC source, I am having a battery itself. Yes, when we go to the market and ask the vendor that please give me the cell of 10 volt, it is just the DC source. I hope you understand this. Yes, so it's a battery voltage that is not changing with respect to time. Let's suppose we have connected our source with, let's suppose, certain, it's an open network. And when I say it's an open network, that potential difference would be equals to EMF, because we have situation something like this. I hope you remember this. It's a V is equals to E minus IR, and if through the circuit, if through the circuit current is not passing, I is equals to 0. If I is equals to 0, then I could write it's V is equals to E. Is it clear? So this is with respect to time. This EMF is constant and it is not going to be changed. Now let's discuss that what is AC source look alike. That this is the symbol. This is the symbol of AC. It's an alternating currents source. Whatever the source we are receiving at our home is AC source. Yes, it has a specification, or I should say ideally it should have this. It's a 230 volt comma 50 hertz. It would be always having a two factors. One one that is the voltage, and another it's a frequency. Always it will be, always it will be described by this two of the parameters, that it would be of 230 volt 50 hertz. In USA it is 60 hertz. So it depends, and it is going to change from country to country according to their requirements. Yes, but in India we have chosen it for the 50 hertz and 230 volt. So this is the representation of alternating current. How it would look like that, starting from 0 reaches to the maximum. This is its amplitude. Again come back to the 0. Again reaches to the maximum but in opposite direction. Again reaches to a 0. Again reaches to a maximum and 0, and so on. So this will continue. This will keep on going, and this is how alternating current can be represented. I hope this is clear. So now let's define certain terms. Let's define certain terms with respect to alternating current. The electric current whose magnitude changes with time and whose direction reverses periodically, that we call as an alternating current, and that can be represented as a function of time. It's a sine function of time. So that could be written as I is equals to I naught sine omega t, where this omega is 2 pi by t, or that could be written as 2 pi into f. Now t, what is it? It's a t is the time period of AC. While I say time period of AC, it is time required. It is time required to complete one cycle. So while I say it's a time period, we should say it's a time required to complete one cycle, and f is the frequency of AC. And we have the relation that time period is equals to 1 by frequency, or vice versa of this. Yes, so it's a t is equals to 1 by f. I hope this is clear. Is it? Great. Now what is alternating EMF? It's an EMF whose magnitude changes with time and whose direction reverses periodically. While I say periodically, I mean after every fixed interval of time. That is what we call as the periodically. That is called as the alternating EMF. It's an EMF whose magnitude varies with time and its direction reverses periodically. That is what we call as an alternating EMF. And alternating EMF can be represented by the relation, which we can say it's a E is equals to E naught sine omega t, where this E is the instantaneous EMF. E is the instantaneous EMF. Alternating current can be abbreviated as AC or AC, but not A dot C or A dot C. It is not like this. It is just the AC. In this situation, E naught is the peak EMF. It's a maximum EMF. That is what we call talking about the amplitude. It represents the amplitude. It will represent that my EMF can have maximum peak to this level, not beyond this. So let's represent this. Let's understood it. Let's suppose this is respected with t or the phi, and one of the sine wave is presented. You can consider it for the current, you can consider it for the EMF. That doesn't make any difference for us to understand. That let's suppose my cycle has been started from this. It reaches to the maximum at A, it reaches to the minimum at B, it reaches to the maximum but in opposite direction at C, and it reaches to the minimum at point D. I hope this is clear. Now this makes a one cycle. This is the complete cycle. Started from the zero and ending on the zero. After achieving two maximums, one in the positive x direction, another is the negative x direction. Negative one is the positive y, another is the negative y. I hope this is clear. Now let's talk about the time period. What is time period? It is time required. Time required to complete one cycle. So from here to here, this time is capital T. Let's talk about the different time. This is when I say this from 0 to, or I should say it's an O 0 to D, it's a one cycle. Then 0 to B, this location, I'm talking about this 0 to B, this is the half of the cycle. And when this is the half of the cycle, this time period is T by 2. This is 0, this is T by 2. 0 to A, it's a 1/4 of the cycle. That's why this has been denoted as T by 4. 0 to C, it's a 3/4 of the cycle, so this is denoted as 3 by 4 of T. I hope this is clear. Is it clear? Is it? Any doubts? No? Great. So this is one of the reference with respect to time. Now let's have a look. Let's have a look with respect to the phase, or with respect to the angle. That we understand that one complete cycle, that means it's in beginning from the 0 to the ending at 360. So when you started with 0, and you ended up by 360 degree, it's a 0 to 2 pi. If it's a half of the cycle, if it's a half of the cycle, this will be starting from 0 and ending at pi, because it's a 180 degree, which is obviously half of the cycle. If you started by 0 and ending at A, then the phase difference between 0 and A, it is of 90 degree, you can say so. When you started by A and when you ended up by B, again it's a phase difference of 90 degree. So do you understand completely what is phase, how I could represent the time and everything? Are you sure? Great. Let's have a look certain quick questions. It says that is transmitted alternating current is transmitted to distant places in the form of, yes, in the form of high voltage and low current, to to reduce the losses it can occur. Next, the correct abbreviation of alternating current is A dot C. No, this is not possible. A dot C dot, no. So it will be represented, or it should be represented like this. It's an AC, not A dot C. I hope this is clear. Now let's discuss about the instantaneous value of the current or EMF. When I say instantaneous, I'm talking about the value at that particular instant of time only. That is what we understood as the instantaneous. So let's look at this. I have represented it for the current, and same can be represented for voltage as well. So this is current versus time graph. This is current versus time graph. So the value of current in an AC circuit at any instant of time is called as the instantaneous current I. Let's suppose I have relation that is equals to I is equals to I naught sine omega t, or I should say it's an I naught sine omega t plus phi. This phase, this complete is the phase difference, or it's a phase of function I. whatever the written, whatever we are going to write in a bracket of sine, or let's say even we can use the cos when we are talking about the sinusoidal waves only. Yes, whatever the written in the bracket of that, that means whatever the theta has been represented, they are called as the phase, or basically the initial phase of the function. Yes, so this is omega t plus 5 for this, or omega t for this is the phase of the function I. Now, what is peak or maximum value of current or EMF? This is the peak value, this is the reference line, and this is the peak value. The maximum value, the maximum value of current or voltage in an AC circuit is called as the peak value, or the crest value, or the amplitude. Yes, this is the amplitude or peak value or crest value. I hope this is clear. Yes, even this is the trough, what we call as, but again, this is the amplitude. We are not having it's a positive amplitude, negative amplitude. No, amplitude is amplitude. It is just the way of representation that it has become maximum in the negative direction. I hope this is clear. Is it clear? So this is just the representation of instantaneous value. Now let's discuss a very very important task. It's an mean or average value, because what happens that when I am having certain DC function, let's say something like this is I versus t, and I can draw like this. Let's say this is plus 5 ampere. So if anyone asks me what is the current through the circuit, I can say it's a 5 ampere, and that's it. But in an alternating current situation, if anyone asks me that what is the current, so I need to ask him that at what time do you want this. If they say at every time, then I can say no, that cannot be defined, because it is alternating. It is keep on changing. Look at this. Let's say this is 0 ampere, this is plus 5 ampere. So every instant of time it is going to be changed. It is going to be maximum at a 5. Again it is going to decreasing and will reach to a 0. Let's say this is minus of 5. Again 0 to minus 1, minus 2, minus 3, minus 4, and minus 5. So in this situation, if someone asks me the current, or if I want to take it as a certain numerical approach, how could I define it? So we have basically two variations. We have basically two options. One of the option is the mean or the average value. One option we are using is the average value or the mean value of the alternating quantity. That could be current, that could be the voltage. But we are using one of the approach as a mean value and another approach as the RMS value. It's a root mean square. So first let's begin with the mean or the average value, and then we will switch to the RMS value. Let's first look what is mean or the average value. We can say that an arithmetic average of all the instantaneous values in a sine wave for half cycle is known as the mean or the average value. First look at this and do remember this. It's an arithmetic average for all the instantaneous value in a sine wave for half cycle is called as the mean or average value. That can be represented as it is equals to 2 by pi of I naught. While I say I naught, I understand that this is the maximum value of I, that we call as an amplitude, or this is the maximum value. This even represents as an peak value. Yes, so I average, it's a 2 by pi into I naught, or I could say it's a 0.637 of I naught, or it's a 63.7 percentage of I naught. Now the thing is that let's understood we have this sine wave. This is 0, this is t by 2, this is t, this is I, this is t. Yes, this is the situation. So why I have chosen only the half of the cycle? Look at this words. Why I have chosen only the half cycle? If I chose the full cycle, look at this, and if I take an average of this, whatever the average of this, let's call it as an A1. whatever the average of this, it's let's call it as an A2. As from the symmetry you can see this, that whatever the positive amount this will develop, this all amount will be gone into the negative. So when I add them, this is positive, this is negative, so this will be the zero. So mean or average value of one complete cycle, please note my word, mean or the average value of one complete cycle, I mean a 0 to t. Yes, I'm talking about the time period. It's for one complete cycle is always 0. That is for sure. And we don't have any doubts on this. So if I take an average value, it would be always 0. So what I need to do is I need to go for the mean value of half of the cycle, because this half cycle could not be a 0. I hope this is clear. Yes. So we always choose a half cycle. So even reason has been mentioned over here. Here half cycle is used because in a full cycle the average current is always 0. Yes. So the reason is 0 to t by 2 is positive, t by 2 t is negative. So this is one of the option by which we are taking mean or average value. So average value of current over half of the cycle, average value of the current over half of the cycle, that could be written as I average, which is equals to 2 I naught by pi. Why I naught is the peak value. I naught, it's a peak value of AC current. Now how could I find it out? If I required, how could I find it out, the average value or mean value of a function from t1 to t2? We have this as a standard relation, that what we are going to do is that when and when you, even you yourself understand what is average value, then what I'm supposed to do is, if I'm taking an, let's say, average of something, then what I'm going to do is I will take this as an I1 plus I2 plus I3 up to IN, divide by total number of samples. So this is the same approach. It's an integration of ft dt, because this current is a function of time. Divide by total number of samples. Let's have a look. Yes, we are doing the same thing. We are not doing anything new. It is the same thing that we understand. The thing is, we are now understanding understanding the differentiation and integration well, and we are going to use it. Why? Because it is keep changing with respect to time. If it is not going to be changed, we have alternate functions too. We will go through it and we will check it, but before we go through it, let's continue with this. Let's suppose I want to find out the mean or the average value of the half cycle, and my function is I is equals to I naught sine omega t. That means, if let's suppose I have been asked to find out the mean or the average value for half cycle, and I have been given that I is equals to I naught sine omega t. Just check it out, or just find out the mean or the average value of this. So what I'm supposed to do is, my basic formula is, it's a 0 to t by 2, because they said half of the cycle. It's a is a function of t dt, divide by integration of 0 to t by 2 dt. So let's just put the value and get it done. While I will write it's an I naught sine omega t dt, divide by 0 to t by 2, it's an I into dt. So when I write this, this is integration of dt, this will be the dt, and if this is dt, this is t from 0 to t by 2, so this is 2 by t multiplied by I naught as a constant. Now integration of sine omega t, when I integrate this with respect to is a sine omega t, integration of sine is the minus of cos, divide by omega, a chain rule, it's a minus of cos omega t from 0 to t by 2. So let's just put the value and get it done. It's a 2 by t I naught multiplied by this omega could be represented as 2 pi by t. So let's represent this omega. Omega as a 2 pi by t. So this t and this t has gone. This 2 and this 2 has gone. Here I have been left with the I naught by pi multiplied by minus of cos 2 pi by t into t. Again, let's take I naught by pi as a constant into bracket minus of cos into 2 pi by t into upper limit minus lower limit. For the upper limit, it's a t by 2. This has gone, this has gone, this gone, this gone. Minus of cos 2 pi by t into 0. This will be cos 0 degree. And when this is cos 0 degree, when this is cos 0 degree, this is minus of 1. This is minus minus plus 1. From here, it's a minus of cos pi. It's a minus of cos pi. Cos pi, it's a cos 180 degree, which is already minus 1, which is multiplied by minus 1. So it is 1. So this will contribute 1. This will contribute 1. It's a 1 plus 1, 2 into bracket 2 I naught by pi. So from this, I have calculated that I average would be equals to 2 I naught by pi. It is, when I say 2 by pi, it is just the 0.637. It is the 0.637. So I will always look at this. It's an I average, which would be 2 I naught by pi, which is equals to 0.637 I naught. I hope this is clear. Is it clear? Is it clear? Great. So when and when I need to find out the average value, when and when I need to find out the average value, my one of the option is I average is equals to integration of I dt divided by integration of dt. This is first option. Second option, it's an I average that is equals to delta q by delta t. It's an I average that is equals to delta q by delta t. Now the question is how to find out the delta q. I can say if it is a graph of I versus t. If it is a graph of I versus t is given, then area, I should say it's an area of I versus t graph. Area of I versus t graph divide by 10. This will give me the I average. Even this can be done. Yes, even this can be done. One more option to find out the delta q. It's an, let's say this is I average, that is equals to delta q by delta t. This delta q could be represented by I dt. I hope you remember this. It's I is equals to dq by dt. Yes, we have discussed all this. We have discussed all this when we were discussing the current electricity unit number 3. Yes, so from this delta q, it would be equals to integration of I dt divided by delta t. So these are the different approaches. These are the different approaches to find out the average value, to find out the average value of current. I hope you understand this. Do you? Do you understand this? Are you sure? Any doubts up till now? Is there anything? Is there? Is there anything? No? So, ready for the questions? Are you ready? Let's have a look. Let's suppose I have been given a certain graph for the I versus t. This is 0 and this is increasing and now this is decreasing. It's a 0. This is 5. This is 10 and this is a 10. This is in ampere. This is in time. This is in seconds. So they say that find out average value of current in 10 seconds. This is the requirement. So when I find out, when I try to find out this I average, I should write it as delta q by delta t. Now delta q, it is the area of I versus t graph divide by delta t. While I'm going to get the area, it would be just the 1 by 2 multiplied by 10 divide by it's a time. This time would be the 10. So this is 2 5s. This is equals to 50 by 10, which is equals to 5 ampere. This would be the average value of the current. This will be the average value of the current in this 10 seconds. I hope you got this. Have you? Have you got this? Great. Let's have one more question based on this. If current through the circuit, if current through the circuit is I is equals to 2 plus 3t ampere, find average value of current in 5 seconds. Find average value of current in 5 seconds. So when I want to get, it's an I average, that is equals to integration of I dt divided by integration of dt. This is integration of I dt. This is equals to 2 plus 3t dt divided by integration of dt. When I write this, it's an I average, that would be equals to integration of 2 plus 3t dt from 0 to 5 divided by integration of dt. It's a t and limits will be a 0 to 5. So this will be equals to, it's a 2t plus 3t square by 2 divided by, this is 5 minus 0, it's a 5 only, and this is from 0 to 5. So this will be, it's a 2 into 5, which is equals to 10, plus 3 into 25, it's a 75 divided by 2. 2 into 5 plus 3 into 25, yes, 75 by 2 divided by 5. So this is equals to 10 plus 75 by 2, it's a 37.5 divided by 5. This is equals to 37.5 plus 10, it's a 47.5 divided by 5, it's a 10 by 2. This is 47 2s are 94 plus 1, 95 by 10, it's a 9.5 ampere. I hope this is clear. So it's a 9.5 ampere. This will be the average. So have you got this? That how to find it out, the average value, how to find it out, the average value of the current. Do you got this? Are you sure? Are you sure? Do you understand this? Do you understand this in a better way? Are you clear with this? Are you? Great. Now let's suppose, look at this. Suppose it is given like this. This is the cycle, and now again it would be a 0. It is something like this. From this, yes, from this it is 0. So this is 0. This is t by 2. This is t. This is basically I versus t, and this is the peak value. And when I say this is the peak value, this is the I naught. So this is the situation. How should I do this? That they will ask me that find out average value of current for one complete cycle. Basically this is the output waveform of half wave rectifier, but at this point of time we might don't understand what is half wave rectifier, so leave it behind and just focus on our question, that what is the average, what is the average value, or what should be the average value for this one complete cycle. So what I understand is that, let's look at this. We have derived something, and whatever we have derived, that was for like this only. It was, we have derived this, it's an I is equals to, it's a I is equals to I naught sine omega t. This was the situation. I is equals to I naught sine omega t. Thus this situation would be something like this only. It's in sine curve, so this is from starting from this and ending from this. We have already taken average of this only. This is 0, this is t by 2, this is t, so we have taken an average of this only. Even the same is the situation with me. Even the same as the situation with me as well, that this is the situation. I need it 0 to t by 2, and from t by 2 to t the current is 0. So what I understand is it's an I average which is equals to 2 by pi multiplied by I naught. This is for first segment only. This is from 0 to t by 2. This, for this its a current is 0, so this is plus 0 divided by, I have taken this two segments. This is the first segment and this is the second segment, so this is divide by 2, which should be is equals to I naught divided by pi. That's it. This is the average value in this situation. I hope this is clear. It's an I naught by pi. This is the average value. Have you got this? Have you got this? Yes, average of this, it's a 2 by pi of I naught. I hope this is clear. One more, I want to make it here only so that we can compare it quickly. Let's say the situation is something like this, that this is the half cycle, this is the another half cycle. Yes, this is 0, this is t by 2, this is t, this is 0, this is t by 2, this is t, and they say find out average value of current. Let's say this is I versus t. Just I'm writing this for the current. Same as the thing, same as the thing for the EMF or for the voltage as well. Only the this I naught will be changing by the E naught, and same is the term. I hope you understand this. This is I naught. So now I want to find out the average value of this cycle. How to do this? So now I must understand that this is the first segment. This should be the second segment. Find out individual average first. So this would be 2 by pi I naught. Again this would be the 2 by pi I naught. So now the average value, it's a 2 by pi I naught plus 2 by pi I naught divide by total cycle. That total cycle begins from 0 to end at the 2. This is 2. So this will be equals to 2 by pi of I naught ampere. This is the average value. This is the average value of this current. I hope this is clear. Is it clear? Is it? Are you sure? Ready for one more? Are you? Are you ready for one more? Let's have a look. The situation is something like this. This is I, this is t. The graph is something like this. This is 0, this is t by 2, this is t. This is, let's say, plus I naught, this is minus of I naught. So the question is find out average value of current for first one complete cycle and second half cycle. So these two are the requirement for one complete cycle and half of the cycle. So for one complete cycle, let's begin with one complete cycle. Let's deal with first cycle. It is just the graph of I versus t. So what I need to do is, it's an I average, it's an area of I versus t graph divide by total time. That total time is t. So when I take an area of this is I naught, this is t by 2, and I can see this is the rectangle, so this is plus I naught into t by 2, this is minus I naught into t by 2, this is divided by time, so plus I naught t by 2 minus I naught t by 2, this will be the 0 by t, it would be a 0. Even you can see this, from analytical point of view, that whatever area this will become, this is the positive, this area will be the positive, and whatever the area I'm going to form over here, this area will be the negative. So that's it, you did it. one of the area is positive, another area is negative, so positive negative will make a 0. That's it. Yes, whatever the area positive, a same amount of area is negative as well, so this will create a 0 for us. I hope this is clear. Is it clear? Is it? Great. So this is I average. It's an area of I versus T divided by T. Now, let's talk about the half of the cycle. So let's work for the second. For half of the cycle, again, I'm going to do the same thing. It's an I average. It's an area of I versus T divided by time. But here it's a half cycle. So this will be the T by 2. For this, I need to area up to this only. It's a I naught multiplied by T by 2 divided by T by 2. This has gone and this will be the I naught. Now, one more thing. If you look at this analytically, then look at this. This is 0. A value is I naught. This is something like T by 4. Value is I naught. This is T by 2. Value is I naught. From the graph, you can clearly understand that value of I naught never changes. Does it clear? Does it clear what I mean to say? If you can observe this carefully, then you will find that this value of I naught never changes. And if certain value never changes, then it must be its average value. I hope this is clear. If someone asks you that find out the average of 5 comma 5 comma 5 comma 5 comma 5, what will be its average? Will you add it? 5 plus 5 plus 5 plus 5 plus 5 divide by 5. Will you do this? Or you directly see this that this is the 5 only. No need to write down the average value because everything is same. Or if someone asks me, no, tell me the average value, then I can say directly that if value is not changing, it itself is the average. I hope this is clear. So this is the mathematical approach that I can prove anytime. But my mind should be also clear that if value does not changes, it itself represents the average or the peak value. This is I naught. I hope this is clear. Is it clear? Any doubts up till now? Is there anything? Are you sure? Are you sure? Any doubts? No? So shall we switch to the second important aspect to understand alternating current? It's a root mean square value. Root mean square. We call it as an RMS value. So for the current, the square root of the mean value of squares, it's a square root of the mean of squares of all the instantaneous value of current over 1 complete cycle is called as the root mean square current. So basically when I say it's RMS, I'm doing the reverse thing. First I will square it, anything I received. Then I will take a mean of it, it's an average value of this. And then I will do the root. So this task to be performed first, this task to be performed second, and this task to be performed last. If you understand this well, RMS is done. Yes, what you need to do is first square it, then take an average of it, and then take a root of it. It is as simple as that. I hope this is understood. Yes, this IRMS could be written as, look at this. This task has been done first. It's an I square. Wait. Yes, this is I square. This has been performed first. Then I have taken the average, and then the third I have taken the root. It's a first, second, and third. So this will be I naught by root 2. We are going to prove this, that how this I naught by root 2 came. But let's remember this at this point of time. It's a I naught by root 2, or I should say it's a 0.707 I naught. This is the RMS value. This is the RMS value of the current. I hope this is clear. Is it clear? Now let's look at this. Let's suppose I am having a current that is I is equals to I naught sine omega t dt. I am having this I is equals to I naught sine omega t, and what I need to do, let us now calculate the value of the average of I square. Why I square? Because what I want, it's an RMS. First task is to square it. So if I'm going to square it, it will look like this. It's an integration of I square RMS. It's an integration of I square RMS is equals to 0 to t I square dt. Yes, I square because I want to square it. So first, if I just prove it, it's an I square dt divide by, I need to take an average. So initially I'm talking about the I square RMS only. Yes, and then I will switch. Then I will switch to the IRMS. I will take the square root on both the sides, and the things will be done. So I square RMS is equals to integration of I square dt divided by integration of dt. If I square this, it's an I square is equals to I naught square sine square omega t. This is I is equals to I naught sine omega t, and this is I square. It's I square is equals to I naught square sine square omega t. Now the problem is I cannot integrate directly sine square omega t. I need to convert it. Now how could I convert this? Let's have a look. It's a cos 2 theta. Cos 2 theta could be written as cos square theta minus of sine square theta. When I write this, I can replace this cos square theta in the terms of sine square theta. It's a 1 minus sine square theta minus sine square theta, and that would be equals to 1 minus 2 sine square theta. This is equals to cos 2 theta. So this 2 sine square theta will be equals to 1 minus cos 2 theta, or I should say it's a sine square theta that could be equals to 1 minus cos 2 theta by 2. So I'm just replacing this theta as an omega t. So this sine square omega t is given. Sine square omega t is given, and I'm just replacing it. This is 1 minus cos 2 omega t by 2 dt. And I naught square is a constant. T is the constant. So this is I naught square by t. I hope this is clear. Now let's just take this 2 as a constant. This I square RMS. This is equals to I naught square by 2t. And I'm going to integrate this. It's a t minus cos 2 omega t will be replaced by the sine 2 omega t. According to the chain rule, this 2 omega would be there, and let's put up the limits. It's a 0 to t. So if you put up the value, of t to the 0, yes, when you put t, it's a sine of 2 omega into t. This, when you put this, is, let me help you. When it is the situation, it's a sine of 2 omega t divided by 2 omega, and you need to put a limit that is of 0 to t. So when it is situation is like this, it's a 1 by 2 omega. Let's keep it aside. This is 2 into omega could be written as 2 pi by t multiplied by t. This is t. This is the first minus. So minus sine of, this is 2 omega into 0. This will simply the 0. So this is 1 by 2 omega. This is equals to this t has gone, and this is sine of 2 into 2 pi, which is equals to 4 pi, minus sine of 2 omega into 0. It's a 0 degree. So when I say sine 4 pi, what will be value of sine 4 pi? If you understand this well, let's understand that this is the circle. This is 0, pi by 2, pi, 3 pi by 2. This is 2 pi. If I rotate for one more circle, it's a 4 pi, 6 pi, 8 pi, and onwards. Same way here, it's a pi, 3 pi, 5 pi, 7 pi. I'm just going to add an amount of 2 pi. Yes, why? Because once you are here, and again you will have, if one more rotation, then it will add 2 pi, 360 degree to your journey. Same way, this is pi by 2, 5 pi by 2, and 9 pi by 2, and onwards. Yes, so if I do this, it's a sine 4 pi. Here sine 0 degree is 0, sine 2 pi is 0, so sine 4 pi is also 0, It's a 1 by, it's a 0 minus 0 and nothing has been left. So this is converted to a 0. It doesn't have any value. It doesn't have any value. So I am here that this will produce, this is going to produce a 0 for me. So I have been left with I naught square by 2t into small t, but small t would be replaced by the upper limit, which is t minus 0, which is only t. So this I square RMS, which is equals to I naught square by 2. If I took a square root on both the sides, if I took a square root on both the sides, this I RMS I will receive, it's a I naught by root 2. This is 0.707 I naught. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you sure? Great. Now, what we could understand is that we can have certain value. You can remember it's an average values. Please do remember this, because in the time of examination you cannot derive this everything. If it's an subjective examination, you can go for it, but if it's an objective pattern or competitive examination, we are not having an that amount of time. So we are going to remember certain average value, that this is sine omega t. I hope you understand that this is the symbol of an average. If you not, please do remember this. 0 to t, if I take an average of sine function from 0 to t complete cycle, it's a 0. If I take an average value, average of cos omega t from 0 to t, it's again 0, doesn't help anything. If I take an average value of sine omega t from 0 to t by 2, it's a 2 by pi. Yes, remember it's a I is equals to I naught sine omega t. I was taking the average value and the average value comes out to be 2 I naught by pi. Yes, so this is 0 to t by 2, 2 by pi. Cos omega t 0 to t by 2, this will be again 2 by pi. I hope this is clear. Is it clear? Is it? Are you sure? Now let's talk about the sine square omega t 0 to t. The average will be 1 by 2. Remember this. Please do remember this. This sine square omega t 0 to t half cos square omega t. It's a 0 to t. Again half. For half of the cycle, it's a sine square omega t. It's a 0 to t by 2. Again half. Do not underestimate, do not think that this is half of the cycle, so I'm going to divide it by 2. No, it is not the case. It is going to square it. We are going to square it and then we are going to take an average of it. So all the terms would be a positive only, whether it would be a for a positive half cycle or negative half cycle. It's a cos square omega t. This is 0 to t by 2, which is equals to half. Now you might wonder that we were discussing the RMS value and why we are discussing now average values. So let's have a look. We are on the same point, that if someone asks me that find IRMS value of given function, suppose my given function is I is equals to I naught sine omega t. Now what I want the RMS value. First task, let's square it. So this will be I square is equals to I naught square sine square omega t. This is first task. Second task, mean it. So I square and take an average value. This is equals to I naught square will remain as it is, but now what is the average value of sine square omega t? Let's look. The average value of sine square omega t, it's a 1 by 2. So this is I naught square into 1 by 2. So this is the second task. And the third task. Third task is to calculate the root value. So this is IRMS is equals to square root of I naught square by 2. So this is equals to I naught by root 2. That's it. You did it. This is IRMS value that we have derived. This is the same IRMS value that we have derived over here. Let's look at this. This is the IRMS. I hope you understand this. Yes. So this is the mathematical approach that will always help. This is the mathematical approach. This will always help. And this is the master formula that you need to remember. I'm going to write it for you one more time. But this is the first approach, mathematical approach. If it is having certain sinusoidal functions that are fixed, certain sinusoidal functions, then I can go with this approach as well. I hope this is clear. Yes, and for this I need to remember average value of this functions, because when alternating currents are used, they are basically a sinusoidal functions. And when I say they are basically a sinusoidal functions, I mean it that they would be of sine or cos, not other than this. So please do remember this. This will help you definitely. Now, master formula of IRMS. Master formula of IRMS. This is equals to integration of its I naught its, or I should say, I square dt divide by integration of dt. But this is I square RMS. This is I square RMS. And if I want an IRMS, then I will take a square root of this. It's an I square dt divide by integration of dt to the power half. Yes, but I will prefer it. Always use I square RMS, and then take a square root of this. This will be bit easier. This feels bit easier basically, that this can be done easily. I hope this is clear. Is it clear? So, ready for one of the questions? Are you? Have you noted it down? Have you noted it? Are you sure? Are you sure? Great. Let's have a look. The question says that if current I is equals to 4 into T, find out RMS value of said current for first 5 seconds. This is the requirement. If current is there, current is given, and that current will be equals to I is equals to 4 into T. You need to find out the RMS value. You need to find out the RMS value of the said current for first 5 seconds. So how should I do this? How should I do this? I can find out this I square RMS, which is equals to integration of I square dt divided by integration of dt. So this is equals to integration of I is 40, it's a 16t square dt from 0 to 5 divide by 0 to 5. This is integration of dt. When I calculate this, this is 16 into t square. While I write t square, this is t cube by 3 from 0 to 5 divide by, this is 0 to 5 dt, which is equals to dt, which is 5 minus 0. So this is 16 by 3 into bracket t cube. This is 5 cube, which is 125 minus of 0 divide by 5. So this will be the 16 by 3 5s are 15 multiplied by 125. It's a 25 5s are, this is 5 3s are. So this has gone. It's a 25 into 600. 25 into 600, it's a 250 plus 150. It's a 400 by 3. But this is I square RMS. So I RMS will be equals to 400. It's a 20 by root 3. I hope this is clear. Is it clear? Is it? Is it clear? Are you sure? Great. Ready for next question? Let's have a look. The question says that find RMS value of full cycle for given function of current. Let's say I is given as a plus b sine omega t. This is my function. This is my function, and I need to find out the RMS value of full cycle. It's a 0 to t for full cycle for a given function of current. So how should I do this? What can be done? What can be done? What I can write is that I is equals to a plus b sine omega t. This is given. R root mean square. First, let's just square it and think step by step. So this I square will be equals to, this is a plus b sine omega t whole square. This will be the a square plus 2ab sine omega t plus b square sine square omega t. This is square. So I have done a first task. Now it's a time for the second task. It's a mean value. So this is I square. If I take a mean of this, if I take an average of this, then a square is a constant number and it doesn't have anything with a average value. It's an a square plus. But look at this. This is 2ab into sine omega t, a average of sine omega t for 0 to t, because they say it for the full cycle. It would be a 0. So this is 2ab into 0 will be a 0 plus b square. B square is a constant, but sine square omega t is keep changing. This is for 0 to t, and its average will be equals to 1 by 2. So I am at here. It's an I square. It's an average value of the I square. This is equals to a square plus b square by 2. This is the average value of I square. Now, so I am having mean, I am having square, I am left with the root. Let's do it. So if I root it, it's an IRMS. That should be equals to root of a square plus b square divided by 2. I hope this is clear. Is it clear? Are you sure? Are you sure? Great. Well done. This is the IRMS. So now if someone asks me, that find RMS value of I is equals to 2 plus 3 sine omega t. So what I can do is I just compare it with a plus b sine omega t and put up the value. It's an IRMS would be equals to root of a square, which is equals to 2, 4, b square, it's a 9 by 2, it's a 8 plus 9, 17 by 2. That's it, you did it. Yes, this is a very common function, but very effective too, because this is having a very good amount of questions that can be derived from this. So please do remember this. This is the RMS value, and you did it. Great job. I hope this is clear. Is it clear? Is it? So can you do this? Are you sure? Can it be done? Can it be done? Are you sure? Great. This is the situation. Now let's work for the next question. The next question says that find find RMS value of E is equals to A sine omega t plus B cos omega t. EMF is given, and you want to find out the RMS value of this EMF. So again the task will be the same. Square it. This is E square. This is equals to A square sine square omega t plus B square cos square omega t plus 2a sine omega t into b cos omega t. I hope this is the situation that you understand. This is the value of square it. Now what I what I want to mean it. It's an average value. It's an e square. So average of sine square omega t, it's a 1 by 2. It's an a square into 1 by 2 plus average of cos square omega t, it's again 1 by 2. This is b square into 1 by 2 plus average of sine omega t, it's a 0. So this is 2 into a into 0 into b into average of cos omega t into 0. So this will be the a square plus b square by 2, but this is just the mean value. So I have squared it, I have mean it, I have been left with the root. So this ERMS could be written as root of a square plus b square by 2. This is the RMS value of the given function. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you sure? This is ERMS that could be written as root of a square plus b square by 2. So do you understand this completely? Have you? Have you understood this? Are you sure? Any doubts? Is there anything? Is there anything which is not to be understood? Everything is clear? Is it? Is it? Great. So do you understand up till now? Are you sure? Are you sure? Great. Let's look at this question. Suppose the question says that find RMS value of given function of EMF. Let's say data is E is equals to 3 sine omega t plus 4 cos omega t. So what we are supposed to do now is we are just comparing it with a sine omega t plus b cos omega t. If this is the situation, then ERMS was root of a square plus b square divided by 2. So this could be written as this is 3 square 9 plus 4 square 16 divided by 2. This is root of 25 by 2, which could be written as 5 by root 2. I hope this is clear. Volt. Is it clear? Is it? So now, will you be able to do this? Will you? Can you do this? Are you sure? Great. Let's look at the next question. Suppose the question is current I is equals to 3 sine omega t plus 4 sine omega t. Find find RMS value of given current. So I'm having this. It's an I is equals to 3 sine omega t plus 4 sine omega t. Do not get it tempted by IRMS that will be equals to root of a square plus b square by 2. No, this is not going to work for us. Look at this carefully. They say 3 sine omega t, even this is sine omega t. So this is simply 7 sine omega t. Yes, and you are going to compare it with its I naught sine omega t. It's an I is equals to I naught sine omega t, and when you are going to compare it with this is IRMS, which could be written as I naught by root 2. And when I say I naught by root 2, this is 7 by root 2. That's it. You did it. Great job. I hope this is clear. So always go with the formula. Always use the formula. But when you are applying a formula, always keep your mind prepared that when and which formula is to be used. I hope this is clear. Is it clear? Great. So let's have some more questions of RMS. Let's suppose a situation is something like this, that this cycle is given from 0 to t by 2, and from t by 2 it's a 0 This is for current, this is versus time, this is its peak value. So they say find RMS value of current for one complete cycle. How will I do this? What is to be done? So what I understand is that first to find out a value of this is my first segment, this is my second segment. And as I understand that this is the function of I naught sine omega t. So what I need to do is look at this very carefully. I want to first square this. It's a square. So if I square this, it's a I naught square sine square omega t. And for this is a 0 plus 0 square. It's a 0. It's a square. Now it's a time to mean. So when I it's a time to mean, I'm talking about the second step. It's an I naught square into average of sine square omega t. It's a 1 by 2 plus this is 0 itself. Now but this is just the sine square omega t and this is 0 square. So when I take an average of this is my first task, this is my second task. So I need to take this as an I naught square into 1 by 2 divide by 2. Why? Because these two segments are there. So this could be written as I naught square by 4. But this is just the second step. It's a mean. Now I need to take a root of this. So IRMS should be equals to I naught square by 4. This is equals to I naught by 2 ampere. I hope you got this. Have you? Yes. So what I'm supposed to do is just the simple mathematics is going to be applied. That first it's an I is equals to I naught sine omega t. First you need to square it. This is I naught square sine square omega t. This is 0. So it's a 0 square. This is equals to sine square omega t. Average of this, it's a 1 by 2. This is I naught square into 1 by 2 plus 0 square. It's a 0. And this is the first segment, this is the second segment. This is going to be averaged out. When I take an average of this is just the I naught square by 4. Now I want to find out the IRMS. This is equals to I naught square by 4 and this is just the I naught by 2. That's it. Let's look at one more variation that will give us a more clear idea. It is something like this. Let's say this is I, this is T. This is first cycle and this is second cycle. This is 0 to T by 2. This is 0 to T. Question same. It's a find RMS value. Find RMS value. This is peak value which could be represented as I naught. So how will I do this? So again we are doing the same thing. This is first segment, this is second segment. This is I naught square sine square omega t. First part. This is about second part. It's an I naught square sine square omega t. This is just the square. This is just the square. It's I naught square sine square omega t plus I naught square sine square omega t. Divide by 2 because these are the two segments. So this will be 2 into I naught square sine square omega t divide by 2. This is I naught square sine square omega t, but I need to take an average of this 2. So this is equals to I naught square into average of sine square omega t. It's a 1 by 2. This is the average of this. Now I have done this everything except root. So it's an IRMS which could be written as I naught by root 2. That's it. So if this is basically a output waveform of full wave rectifier that we are going to discuss in the semiconductors physics. So this is output of the full wave rectifier and this is its RMS value. It's an I naught by root 2. I hope this is clear. Is it clear? Is it? Great. Let's look at next question. So this is I, this is T. It is conventional practice that we use an I, but if you have been given an EMF or if you have been given voltage, you can use the same thing. So this is V versus T is given. This is something like that. Yes, this is, let's say, plus I naught. This is, let's say, minus I naught. This is 0, T by 2 T. Yes, the question is find IRMS of of given situation. You need to find out the IRMS value of this situation. How will you do this? So to find out the IRMS, first I need to square it. So let's square it. It's an I naught square plus I naught square. Yes, then I need to take an average it. This is first segment, this is second segment, this is 2. So this is 2 I naught square divided by 2, which is equals to I naught square. And last but not the least, I need to find out the root of this. If I need to find out the root of this, it's an IRMS that would be equals to root of I naught square. When I take a root of I naught square, this will be the I naught. That's it. You did it. Great job. I hope this is clear. Is it clear? Is it? So are you done with this? Now will you be capable to calculate RMS value of this? Are you sure? Are you sure? Any doubts up till now? Is there anything? Is there anything? Any doubts? Is there? Is there? No? Great. So let's just wind it up the session over here. This is all about the introduction to alternating current. We have introduced the alternating current to you guys, as well as we have already find it out the average value and RMS value of this. So please revise this, please practice this. If you practice it good, then this all are the units which are much easier, and this we have a command over this in a very short span of time. Please do this, this will help us. Thank you, have a good day, take care, bye bye.